Hello guys, today we are gonna be learning a new physics topic that is pseudo force. Okay, so we have learned some Newton's laws in some videos, one or two videos. We have learned about the first and second laws that are there, that are the most main laws that are connected to each other. I have learned those laws. We have also learned about what is acceleration and when force happens to occur, and unbalance, balance, net force, all those important concepts. So for just telling you some part of it, I will just tell you some part of it to remind you about um, the things, and so that I can connect with the new topic that we are going to do today, that is pseudo force. So let's start. So first we're going to look at Newton's first law. So Newton's first law tells about inertia. It is the law of inertia. It tells about that an object, if it is at rest, if this is your object, and if this object is at rest, then if there is all the force, then if there is no net force acting on this object, then there is a tendency of an object. The what is inertia, I'm telling you, it is a tendency of an object to stay at rest or move continually. So it's not accelerating. So that is opposite to acceleration. Means what I'm going to tell, that inertia is a tendency of an object to continue moving, which means or continue to be at rest, which means no acceleration. Okay, so when this happens, basically that tells that's what Newton's first law tells, that when there are balanced forces, when there is no net force acting on this object, suppose we put a kick on this ball and we have the friction force, so we have two forces acting on the two opposite sides. Now if this force magnitude is same, then it is called as balanced force. Then there is no net force acting on this ball, so it will continue to be at rest. Okay, now Newton's second law tells that when the I will not draw leg, I will draw arrow. If the force applied by me, and I will draw a small arrow, so which force is more? By me. So what will happen? It will accelerate. Means if it is at rest, then it will come at motion. So whenever there is an unbalanced force, or whenever there is a net force acting on this object, then we call that there is a force acting on this object. When there is an acceleration, only when there is an acceleration to an object, then we call that there is a force applied to this object, a net force applied to this object. But when the forces are balanced, then there is no net force acting on this object, there will be no acceleration. That's what Newton's first law tells, and it also tells about why it happens, because of the law of inertia, that is a tendency of an object. That also I have told you in one video. Now we'll look into pseudo force, that is relating to Newton's second law. So here we're going to take the same example, and suppose here there is and you are on top of this ball. It's a big ball. That's just an example. Okay, and there are unbalanced force here. So suppose the ball was at rest first, and then suddenly the force was applied, and one side the force was applied more, means there was unbalanced force, so there was a net force acting on this object, and so the ball moved forward, it accelerated. Am I right? So when you will go as you go, you'll feel a backward force that is going to pull you back, and that is the pseudo force. So what this thing tells us is about inertia. This pseudo force is related to inertia. Now we all know it is a tendency of the ball to stay at rest. It is a tendency of us to stay at rest on this ball. It's a tendency of me to stay on this ball, to not move. Okay, every object has a tendency. So more the mass of an object, more the tendency, more the inertia of an object. So I will I will I will try to not accelerate. That is a tendency. That is inertia. I will try not to accelerate. Not to accelerate is inertia. I will do what it is doing. Okay, but here unfortunately there is a force, there is a net force acting on this ball. As I am on top of it, is also moving me with it. Now, why there is a backward force? Because I was at a place where I did not want to move. I did not. I I was just staying stationary, right? So it is my tendency to stay stationary, not to move. Okay, it is a tendency not to move. That is my tendency not to move. But there is an unbalanced force. There is a net force acting on me, so I have to move. It moves, but that but there is a backward force also, because there was a tendency of me to stay at rest, but I moved, so there is a backward force. So pseudo force is related to inertia. It always acts at the opposite side of the acceleration. So acceleration is this side, then pseudo force will be that side. Okay, because why does pseudo force occurs? It's because I wanted to do what I was doing. Okay, I wanted to stay at rest, but I moved because of unbalanced forces, because of net force acting on that object. I wanted to stay at that position, so there is a backward force because I wanted to stay. There was an inertia. Okay, I hope you're getting it. Now this example is okay. Let's give you another example. Suppose here you're standing in a bus. Now real life examples. And when suppose the bus is moving, the bus is moving constantly. I'm just taking an example. So suppose the bus is moving constantly. It's not changing its speed. It's not changing its velocity. It's not accelerating. It means that it's not changing its direction. Also, it is not changing its speed. This bus. Okay. So basically, it is not accelerating. It is constantly moving. It is constantly moving. Okay. Now, when this body accelerates, so when can we tell that if there suppose this bus is there and that bus is not changing its speed, not changing its velocity, it's not accelerating? When it happens, yes, you're right. It happens when there are balanced forces, when there is no net force acting on this ball. But here there is a some kind of that only happens because that happens. So this bus is not accelerating right now. But suppose there is some kind of obstruction here. Suppose there is some kind of another bus and it needs to stop. So it makes a force on the opposite side. So there are two forces acting on, and and after that this bus was moving on that side, okay, and it was not accelerating. Now he had to stop, and this force exceeds this force. I'll rub this off. This is the speed, not the force. So there is a force acting on the opposite side of where the bus was moving, and then it suddenly stops. So what happens here? So there are unbalanced force, means there is a net force acting on this ball, and thus it is making it stop. So the bus has come to a stop. Why? Because of a net force acting on this bus. Because there are unbalanced force acting on this bus, there are more forces on this side by the brakes on the opposite side. So it is coming to a stop. There is some we should tell that there is some net force now acting on this bus, because it has come to a stop. It has accelerated, right? It was moving, and then it's come to a stop. It has accelerated. We should tell deaccelerate. That's the correct word. It means to slow down. So it has accelerated basically because it has changed its velocity. Okay, that's how we can see. Now if you are inside the bus, you're standing, and now the bus was moving. Also, I was not moving in my reference frame. From outside, you can see that you're moving. Okay, you're moving with the bus, right? And you had a tendency to keep on moving, right? You had a tendency to keep on moving. That's inertia. It's always a tendency. But unfortunately, unbalanced force, net force, and so you stopped. But you accelerated on this side, accelerated on this side. So when the bus stops, what do you feel? A pseudo force. You go forward. Why? Because acceleration was on that side, the back side. Okay, right? It was not. It has come to a stop. So the acceleration is on the back side, on the opposite side. So the pseudo force acts on the opposite side of the acceleration, on this side, right? And now suppose another example. Same bus we're gonna take with the first example that we did. Suppose the bus is moving with a constant speed, and now it moves zoom. It moves more fast. It has taken his accelerator and gone. Boom. He's moving more fast. So what happens? Here there is an unbalanced force. There is a net force acting on this ball. We should tell net force. There is a net force acting on this bus, and so it has accelerated. And so what will happen to me? Where is the acceleration? On this side. So where we will feel the pseudo force? Opposite side. So whenever we accelerate, we are moving. Suppose moving, and then suppose moving, and then we then it has pushed the accelerator, and so we go backwards, right, on the seat. So that happens because of the pseudo force. That is the inertia. It happens because of the inertia of this. It happens because the inertia. It happens because of the inertia. That is the pseudo force. So I hope you understood about pseudo force in the couple of examples that I gave you, and I hope you understood about net force, unbalanced force, and some parts. If you have not, because I have explained shortly, if you have not understood, then you can look into my previous videos. There is one video where I have explained it, so I will paste the link in the description below. You can watch it, and this chapter, this topic, which is pseudo force, is related to that. So I've explained a little part of that, and then I've explained what is this pseudo force and how it happens. So I hope you understood it. One common example of pseudo force is centrifugal force. Okay, centrifugal force that happens on rotating bodies. This is an example of pseudo force. I want you to relate. If you have understood this pseudo force, I want you to relate with centrifugal force, right? So centrifugal force is a pseudo force. How it is, you can write me in the comment section below. You can search in Google, or do some understand it, and do some exploring and find it out. So how centrifugal force, this centrifugal force is a pseudo force. How it is, right? So I hope you understood pseudo force. If you have understood, then please subscribe to my channel, and also like and share. We'll meet in the next video. Thank you and goodbye.